This is Chapter 4, Elbow, from the 11th edition of the Textbook of Radiographic Positioning and Related Anatomy. This lecture is going to deal with just the elbow, and we will start with this on page 129 of your textbook. This is the distal humerus. So this correlates to figure 4.16 on 129. And there's a few acronyms that tend to go with the elbow. Now, these acronyms that are in red here, this is not in your, this is on the cheat sheet that you have for week 1. Actually, this is under week 2. So the elbow, as far as what bones make up the elbow joint, that would be the distal humerus and the proximal radius and ulna. So with this, typically we refer to this as RCUT, meaning that the radius articulates with the capitulum of the humerus and the ulna articulates with the trochlea. So you can see right here, the radial head articulates with the capitulum and the ulna articulates with the trochlea. That's what actually forms the elbow joint. So this RCUT just helps you to understand what bones articulate and where they articulate. Okay. So when we're looking at this, realize that radius is always thumb side, ulna is always 5th digit. And then you can see all this anatomy. This is the body of the humerus or the shaft. You've got the coronoid fossa. You have medial and lateral epicondyles. You've got the radial fossa here, head of the radius. This right here would be the proximal radial ulnar joint. You've got the trochlear sulcus or groove, and then you've got the trochlea right here. So all of this is found on figure 4.16 on 129. And then to look at this radiographically, this is a radiograph basically of that figure we just looked at, 4.16. Same exact setup. You've got radius here, the neck of the radius, the head of the radius, ulna. The radius articulates with the capitulum, and the ulna articulates with the trochlea. You can see lateral and medial epicondyles. Those are important when we look at elbow positioning. You've got the olecranon fossa here, and that is the olecranon process of the ulna. The trochlea sits right here, and then you've got the radial or the bicipital tuberosity. So the radial head, radial neck, and tuberosity come into play when we look at the external rotation of the elbow. It kind of isolates all of this so that there's no superimposition. When we look at the internal rotation, that oblique on the elbow, it demonstrates the coronoid process in profile, this right here. Okay, so knowing the anatomy both in picture form and on the radiograph, we've discussed before, is extremely important. The lateral elbow, this is also on page 129, figure 4.17. Again, this would be the humerus, the distal portion of the humerus, and this is proximal ulna and proximal radius. So the lateral elbow is made up of all of these areas. You've got the coronoid process right here. You've got the trochlear notch or the semilunar notch right here. The olecranon process, the epicondyle. You've got the ridge of the capitulum and the trochlea. Those form one of the 3 concentric arcs that we need to know that we have a perfectly lateral elbow, because this should form a 90-degree angle between the distal humerus and the proximal radius and ulna. Here you've got radial head, neck, and radial tuberosity. That'll be right here. And again, the coronoid process, that little beak often is fractured, and that is demonstrated best on the internal oblique of the elbow, or the 45-degree medial. On the external, or the 45-degree lateral oblique, that demonstrates the radial head, neck, and tuberosity free of superimposition from. When we look at the three concentric arcs, this is also on page 129 of your book. And the three concentric arcs, they tell you to know that you have a true lateral. One would be when it's flexed a perfect 90 degrees. And at that 90 degrees, you visualize the three concentric arcs that they list here. Okay? You've got the smallest arc is actually the trochlear sulcus, which is right here. You've got the second arc is double lined, and it's the outer ridges of the capitulum and the trochlea that line up right here. And then the third arc is actually the trochlear notch of the ulna. If the elbow is slightly rotated, the arcs will not appear symmetrically aligned, and that means that that elbow joint space would not be open. So you can see right here, you've got the trochlear sulcus right in here. Then you have the outer ridges of the capitulum and the trochlea here. And then you've got the trochlear notch right in here. So this, it almost reminds me of like a figure 8. If we do the highlight, let me see if I can do this. I feel like this right here, if you look, this area right here always to me reminds me of, if you have that perfect figure 8, even though it resembles somewhat of an 8 or almost like an infinity symbol, that's what you're looking for to know that you have a perfect lateral elbow. And that is referenced in 4.17 and 4.18 on page 120. Okay. As far as the AP elbow, reviewing this anatomy, this is figure 4.19 on page 130. So all of these areas are important. If we start at the beginning with A, this is the medial epicondyle. Far more palpable than F, which is your lateral epicondyle. This one is more prominent and it sits medial. Letter B is the trochlea. C represents the coronoid tubercle. D is the radial head. E is your capitulum. Like we said, RC, radius, articulates with the capitulum, and then the ulna articulates with the trochlea. F, we said, is the lateral epicondyle. And then you don't have H on here. This is the olecranon process. You can see from the, right? So that image right there would be an AP fully extended elbow. That's what we're looking at in that image. Right? So radius is thumb side, ulna is 5th digit side, and then you've got distal humerus. When we look at the lateral elbow, figure 4.20 on page 130, if we look at letter G on here, this is the epicondyles superimposed. When we look at I, this is the trochlear sulcus right here. J is the trochlear notch right in here. And then K, you have the double outer ridges of the capitulum and the trochlea. That's what's referenced here. So these three concentric arcs tell us that we have a pretty near perfect lateral elbow. Got this 90-degree bend in the elbow. L represents the coronoid process of the ulna. M is the radial head, and N is the radial neck. Radial tuberosity would be right here. So that is a very good lateral elbow. When we look at the elbow joint, this is on page 131. So it is a synovial joint. and it is considered diarthroidal or freely movable joint. It's also a ganglymus joint or a hinge joint, meaning that it opens and closes like a door. It allows flexion and extension. Okay. When we look next at the rotation movements of the elbow, this is on page 132. So you've got an AP right elbow. Notice how the radius and the ulna are partially superimposed all through here. So that is an AP elbow, full extension. This is external rotation, and this comes into play because the purpose of the obliques on the external rotation, that demonstrates the radial head, neck, and tuberosity free of superimposition. We have another acronym that's ERIC. So ER on the external or the 45-degree lateral oblique, it demonstrates radial head, neck, and tuberosity free of superimposition. On the internal rotation or the 45-degree medial oblique, that is IC. The acronym is ERIC. So this does the ER. This one is IC, meaning on the internal rotation, it demonstrates the coronoid process in profile. This is that little bird beak right there. And oftentimes you can see a fracture in that on this particular image. Okay, so these are important. We have 4 images on the elbow. We do AP, both obliques, medial and lateral, 45-degree rotation, and then we do a lateral elbow as well. This is on page 133, and they reference that on the lateral elbow, that is exactly where you are going to look at. These are the areas that you would look at to see a positive fat pad sign. Okay, so on this right here, letter D is the posterior fat pad. C represents the anterior fat pad, and E represents the supinator fat stripe. Right? So the fat pads, basically if you have a positive fat pad sign, then that is indicative of injury, basically, either fracture or fluid accumulation. There's some type of injury or trauma that can cause these to be positive or to be seen. They reference that the anterior fat pad, which is letter C, trauma or infection can cause that to be elevated and more visible. But typically these are only visible on a true lateral at a 90-degree angle. Right? The posterior fat pad, which is letter D, is in the olecranon fossa and typically not visible when there's a negative study, meaning there's nothing wrong. If you visualize the posterior fat pad on a lateral elbow, then it means there's a change in that joint, which has caused it to change position. So ideally, it would be it's indicative of the presence of a pathology. Okay, it's pathology, fracture, something along those lines. So posterior fat pad, anterior fat pad, and the supinator fat stripe. Once you see these shown positively on a radiograph, it's hard to not see them if they're there. Typically, they almost look like an area of lucency that you can see in these 3 specific areas. You can see here there is significant trauma. This is a fracture in the ulna, and they've actually fractured the olecranon process. And it's not a very clean break. You can see it's very jagged. So not ideal for that patient for sure. As far as elbow positioning, recognize that, like we said, there are 4 positions of the elbow. The routine positions are AP, a 45-degree external oblique, and then a 45-degree internal or medial oblique. When they reference external, basically they're saying it's lateral, like you're leaning the patient backwards. So a 45-degree lateral oblique or a 45-degree external oblique. Sometimes they'll use those interchangeably. And then the 45-degree internal or medial oblique. And then we also do a lateral. So these four, AP, lateral, and both obliques. And these, remember I told you that acronym of ERIC, E-R-I-C. So the external will demonstrate the radial head, neck, and tuberosity free of superimposition. And the internal will demonstrate the coronoid process in profile. The technique for all of these is 70 kVp at 2 mass, just like we used for forearm. All right. Here we have an AP elbow, and this is fully extended. So this is on page 163 of your textbook. And ideally, this is how you want the patient to be able to be, with their arm fully extended and able to lie their elbow on the image receptor with this completely open. That's not always the case. Sometimes the patient is not able to fully extend their elbow. And if that's the case, in the next slide, we'll look at what some of our options are. When the elbow is fully extended, the epicondyles, both the medial and lateral epicondyle, will be parallel to the IR. And the central ray is actually to mid-elbow joint. Now, you'll remember that we spoke for wrist and for forearm and for elbow. The shoulder, the elbow, and the wrist all have to be in the same plane. So the patient either has to slouch, or you have to raise the table up and adjust your SID, or you could elevate the image receptor and again adjust your SID to accommodate a 40-inch tabletop. So all of it has to be in the same plane, and central ray is mid-elbow joint. If the patient cannot fully extend their arm, like in this picture, then what you can do is 2 partially flexed AP projections, and those are shown on page 164. So if the patient's arm was like this and they could not straighten that anymore, then what you're going to do, a lot of times this happens during trauma, you're going to do 2 APs. One, the humerus is parallel to the IR, and in the other, the forearm is parallel to the IR. And central ray would still be mid-elbow. So instead of 1 AP, you're going to have to do 2, one with the humerus parallel and then one with the forearm parallel. But these are typically done in cases when the elbow cannot be fully extended, so typically due to trauma. These are comparing the 3 different images we just spoke of. So this is an AP elbow fully extended, and the radius and the ulna are superimposed proximally on the 2 that we would have to do if the elbow could not be fully extended. This image is with the humerus parallel to the IR. This one is with the forearm parallel to the IR. So if you can't do one fully extended, you are forced to do 2 images with each long bone parallel in each of the 2 images. There also is what's called an acute flexion projection. This is on page 165. Okay, so with this, if the patient was in acute flexion, meaning they could not open that at all, then what you would do is you would have the central ray perpendicular to the humerus, and on this one, the central ray is perpendicular to the forearm. So in this one, you're imaging and centering perpendicular at a 90-degree angle to the humerus, and this one you are coming in perpendicular to the forearm. Typically, on the one that's perpendicular to the humerus, you're midway between the epicondyles, and on the one where it's perpendicular to the forearm, you're angling as much as needed, depending on how their forearm is, but you want to be at a 90-degree angle to that forearm. And then both of these images would come out. So this is the one where you were perpendicular to the humerus. This one you would be perpendicular to the forearm. And that is when the patient is in acute flexion, meaning that they're not able to straighten their elbow at all. Okay? So ideally, just like if they can't, if they're in partial flexion, you have to do 2 images to be equivalent to 1 AP fully extended elbow. If they were in acute flexion, again, you would have to do 2 projections to be equivalent to the 1 image that you would take if the elbow was fully extended. The oblique projections of the elbow, there are 2. There are what's called a 45-degree medial oblique, or sometimes they'll refer to it as the internal, and there is a 45-degree lateral oblique, sometimes just called the external. So this is where that ERIC comes into play. So the medial oblique is actually on page 168, and this lateral 45-degree lateral oblique is on page 166. So we're going to look at these in the order that we would do them. So we would originally do the AP fully extended, and then we would go into the external oblique first, or the 45-degree lateral oblique. So on this particular image, if you look on page 166, the patient is seated at the table with their shoulder, elbow, and wrist in the same plane. You're at a 40-inch SID tabletop. Your technique is 70 at 2. And on this one, this is going to represent that external oblique demonstrates the radial head, neck, and tuberosity free of superimposition. Okay, so the patient would be seated with their arm fully extended, everything in the same plane. You would supinate their hand and they would rotate laterally or lean back so that the entire arm are at a 45-degree angle to the IR. And your central ray is mid-elbow joint. And if done properly, then this external or 45-degree lateral oblique should demonstrate radial head, neck, and tuberosity free of superimposition from the ulna. Then we would do what is called our 45-degree medial oblique or internal rotation. And this takes care of the last 2 letters in the acronym ERIC, because on the internal oblique, the coronoid process should be in profile. This little bird beak right here. So on this one, the patient literally has their arm back to AP fully extended. The shoulder, elbow, and wrist are in the same plane, and the patient would pronate the hand palm down, and that typically will place the elbow in a perfect 45-degree medial oblique. The central ray is still mid-elbow, and like we said, if done correctly, the internal should demonstrate the coronoid process in profile, because this is where you're looking to see if there's any fractures. And again, that is on page 168 of your textbook. The last image in our four picture series is a lateral elbow. This is on page 169 of your book. Again, The patient is slouched so that shoulder, elbow, and wrist are in the same plane. Their elbow would be flexed 90 degrees. And you want both the humerus and the forearm parallel to the IR. You're still at a 40-inch SID. You're likely at a 10 by 12, 70 kVp at 2 mass. And your central ray now would be mid-elbow joint, which is found approximately 1.5 inches medial to the olecranon process. What does that mean? It means that the olecranon process is this right here, and you're coming 1.5 inches medial. Typically, it looks like one crosshair runs through the middle of the humerus, and the other one runs through the middle of the forearm. The key with this, and most often what I see done mistakenly, is you have a 90-degree bend in the elbow, but if you pronate that hand and put the palm flat versus the wrist and the hand being in a true lateral, these will not come out right. The bones will not appear as they should on the radiograph. So you rotate the hand and wrist into a true lateral, thumb side up, and your central ray is mid-elbow joint, which is found 1.5 inches medial from the olecranon process. Okay, and if that is done correctly, then you will have this perfect lateral right here. We can look at our 3 concentric arcs and know that that looks like a perfect figure 8 or infinity symbol right there. There's a perfect 90-degree angle. We can see ulna and radius and distal humerus. That is a very nice lateral elbow. So again, 90-degree flex to the elbow, shoulder, wrist, and elbow in the same plane, 70 at 2, 40-inch tabletop, 10 by 12, and you want a perfect true lateral from humerus and radius and ulna at a 90-degree angle, but then wrist and hand also placed laterally so that the radius and the ulna appear properly as they should in the image. Your central ray from olecranon process is 1.5 inches medial. So you'd palpate olecranon process and go 1.5 inches medial, and that typically will put you in the middle of the humerus and in the middle of the forearm. So you're right about there. All right. Now beyond that, if you look on page 170, 171, they do show you some specialty views of the elbow. On 170, they have the trauma axial lateral medial. That's called the coil method. And this is done typically to look for pathology or trauma to the radial head or the coronoid process. These come in handy, especially if the patient can't extend their elbow fully or if they can't perform the oblique projections. Okay? So if you look on page 170, they show you part position 1 is for the radial head, and part position 2 is for the coronoid process. So these are the coil method. And then on 171, they have the radial head. That is a lateral medial projection. And there are 4 separate images taken, and the difference between them is the rotation of the hand and wrist. So if you look at those 4 pictures where they're demonstrating how the hand movement is, the first one, the hand is supinated with maximum external rotation. Then you've got a lateral hand position, pronated hand, and then maximum internal rotation, all with a 90-degree flex in the elbow. And that would look at or demonstrate fractures of the radial head or neck. Okay, so 170 and 171 are some specialty views of that. And then beyond that, in the rest of the chapter, you have some images for critique. The ones of the elbow, I would look at those and see if you can see what exactly is wrong with the image or what positioning was done properly and what was done improperly. Those are on page 173 and 174. So if you had any questions or comments, any confusion with the elbow, make sure to write your questions down, and then when we meet next, we can discuss that and try to clear up any confusion. But until then, I hope you have a great rest of your day. Thank you so much.